This video is on ionic compounds, names, and formulas. So an ionic compound is where we have a metal plus a nonmetal. So on your periodic table, that is a metal, anything to the left of the staircase, or zigzag line, plus a nonmetal, anything to the right of the zigzag line. When we write these, we always write the metal first, the nonmetal second. Just like reading your periodic table left to right, metals on the left, nonmetals on the right. That's how we write ionic compounds. When we name and write formulas for all metals except in groups 1, 2, and 3. So groups 1, 2, and 3 are going to have special rules. Everybody else, so anything that falls down here, all your transition metals and your inner transition metals are going to have these rules. When we write their formulas, we're going to look at their ions because it's ionic compound. And our Roman numeral in the formula is going to tell us the charge of the metal. The number of valence electrons needed to get to 8 is going to be the charge of the nonmetal. If we look at our nonmetals on the periodic table, group 7 needs 1 valence electron, so has a charge of -1. Group 6 needs 2, so has a charge of -2. Group 5 needs 3 electrons to get to 8, so it has a charge of -3. And these are always going to be the case. They're never going to change their charges. Our next step is going to be to crisscross charges down, and we'll only write the numbers, no plus or minus, and then we'll reduce subscripts. So let's do our first one together. We have iron 3 oxide. So I start by writing my formulas. Iron oxide came from oxygen. I then turn them into ions because they're an ionic compound. So my Roman numeral gives the charge of the metal. So my charge of 3 tells me the charge of my iron, so that's +3. Oxide came from oxygen, so number of electrons needs to get to 8 is my nonmetal. So oxygen needs 2, so has a charge of -2. Then it tells me to crisscross down charges only, write numbers, no positive or negative. So it means my 3 comes down and my 2 comes down. They crisscross down, so it means I have Fe2O3. So that's iron 3 oxide. Going the reverse direction, we can name our compound. When we name this, we write the metal name first, then parentheses we put the Roman numeral charge of the metal, our nonmetal name with our stem plus our IDE ending. We need Roman numerals because the electrons in the d orbital can be donated even though they're not true valence electrons. So if we look any of these transition metals plus any of these metals here, we can pull out these d electrons as valence electrons and they can be used in bonding. Group 3 this doesn't happen to, but it does in groups 4, 5, and 6 at the bottom. Thus we need Roman numerals because their charges can vary. So if I'm naming here, my first letter is V, which is vanadium. I need some sort of charge, so Roman numeral, and then Cl is chlorine, which becomes chloride. I need to figure out what my charge of vanadium is. So I look at my charges here. There's nothing here, which means that my charges must have reduced into 1 and 1. So they had to have been the same. Chlorine has a charge of -1, so that means that my vanadium must have also had a charge of -1 for them to be 1 and 1. So I have vanadium 1 chloride. For groups 1, 2, and 3, zinc and silver, their charge for group 1 is +1, for group 2 is +2, and for group 3 is +3. Zinc is always +2, and silver is always +1. We're going to follow the same steps, except here our group number is going to tell us the charge of the metal. And it's just like before, our nonmetal's charge is the number of valence electrons needed to get to 8. We'll crisscross charges down, only write numbers, and reduce subscripts. So I have magnesium nitride. Magnesium, Mg, nitride comes from nitrogen, which is N. Magnesium here is in group 2, so that means its charge is +2. Nitrogen here is in group 5, needs 3 more valence electrons, so its charge is -3. So magnesium is +2, nitrogen -3. I crisscross my numbers down, so I get Mg3N2. Tells us to reduce subscripts. My 3 and 2 are already reduced. Going the opposite direction, I name them. No Roman numerals needed, because for every case, group 1, 2, and 3 become +1, +2, and +3 respectively. So here I have Na, which is sodium, metal name first, and then my nonmetal, I use my stem, so the stem for chlorine is chlor, and then I add my IDE ending. So NaCl is just sodium chloride. Lastly, we can have an ionic compound with a polyatomic ion. A polyatomic ion is a multiple atom ion. Poly for multiple, atomic for atom, and then ion. We're going to treat these like a unit, and we're going to use parentheses around our polyatomic ion when we write them in formulas. Polyatomic ions follow a pattern based on the number of oxygens. So usually a polyatomic ion is an anion, so a nonmetal, bonded with some number of oxygens. And there's others as well. When we have multiple oxygens bonded to a nonmetal, we have a system of naming. The most oxygens that can be bonded to it can either be called chlorate or perchlorate. Because with chlorine, we have our base of chlor, and then we add endings to them and sometimes suffixes. So ClO4 is perchlorate. Then we drop 1 electron from 4 to 3, so we just have chlorate. 1 less electron makes it chlorite, and then 1 less than that makes it hypochlorite. Now you won't have to memorize these. I'll have a chart for you to just find them, but I wanted you to understand where the names come from based off the number of oxygen. Every polyatomic ion is an anion, so it means they have that negative charge, except for ammonium, which has a positive charge. You'll also notice that acetate can be written two ways, of H2O3 or HOO. Those aren't right. We'll look at those in class. When we name these, we look at what's in parentheses. That's our polyatomic ion. That tells us to check our chart that we'll have. And then we'll always have our cation, our metal, to start. Notice that here our parentheses are around the hydroxide, which is the OH, not around the outside of the OH. So when I do something like NH4, I look at my chart and that's ammonium. And then after that is S, which is sulfur, which becomes sulfide. So nonmetal, keep the stem at IDE. Going the other direction, I have calcium, which has a charge of +2. And then I have acetate, acetate is C2H3O2. It has a charge of -1, so I put my parentheses around it, C2H3O2, my parentheses, that has a charge of -1. Then I crisscross my numbers down to the outsides of my parentheses to get Ca parentheses C2H3O2, and my 2 comes on the outside because I have 2 acetates. Otherwise, it'd be written Ca C2H3O2, 2, and that would mean I have 22 oxygens.